we wish to evaluate integral from 0 to pi over 2 of sine of x to the 8th power dx. Obviously, trying to anti-differentiate this right away using trig identities is going to take a very long time. So let's try to avoid a straightforward anti-differentiation if we can avoid it. So how do we integrate this? Well, one thing you may suggest is that maybe we can apply integration by parts, because the entire point of performing integration by parts is to reduce our original integral to another integral that's easier to evaluate, or something that's going to simplify the entire process. And who knows, maybe if we do integration by parts, our exponent of 8 may get smaller, so it's easier for us to anti-differentiate what's left. So let's apply integration by parts, and we can break apart sine of x to the 8th power to sine of x to the 7th power as u, and sine of x dx as our dv, because we must be able to integrate dv, and the sine of x is very easy to anti-differentiate. So I'm just using standard integration by parts. Integral of u dv is equal to uv minus integral of v du. From this, we know du, differentiating this, is 7 times sine of x to the 6th power times cosine of x, and v, anti-differentiating this, is negative cosine of x. So we get that our integral is uv, or negative sine of x to the 7th power times cosine of x, and we are integrating from 0 to pi over 2 minus integral of v du, and we have minus, so let's change that to plus integral of v du, and when you multiply these two, we are going to get 7 times sine of x to the 6th power times cosine squared of x, cosine of x and another cosine of x. And of course in du I was supposed to write dx, so here's our dx, and our bound is from 0 to pi over 2. Now realize that this entire thing is going to be 0, because cosine at pi over 2 is 0 and the sine at 0 is 0. So this entire thing is going to be 0. So we see that our integral from 0 to pi over 2 of sine of x to the 8th power dx is equal to 7 times integral from 0 to pi over 2 of sine of x to the 6th power, and cosine squared I'm going to replace with 1 minus sine squared of x. And I'm doing this just to retain the symmetry. We had sine of x to the 8th power, and when we split this up, we are going to have sine of x to the 6th and sine of x to the 8th power. And it looks like maybe we can form some kind of relationship to our original integral by writing the entire thing in form of sine. Anyway, what is this going to be? Well, we are going to get, when we distribute and split up the integral, we have 7 times integral from 0 to pi over 2 of sine of x to the 6th power dx minus 7 times integral from 0 to pi over 2 of sine of x to the 8th power dx. I'm just distributing this and splitting up the integral, so that's what we get. And we see right away that we have two equivalent integrals, integral from 0 to pi over 2 of sine of x to the 8th power, which is what we want to find. So let's move this integral over to the left side. So we have 8 times integral from 0 to pi over 2 of sine of x to the 8th power dx is 7 times integral from 0 to pi over 2 of sine of x to the 6th power dx, and dividing by 8 to both sides, we get that integral that we want with the exponent of 8 is going to be 7/8 of the same integral, except that we have exponent of 6. What do we do now? Well, look at this. Maybe we can apply the same thing to integral from 0 to pi over 2 of sine of x to the 6th power dx. And maybe now it's going to simplify to something times integral from 0 to pi over 2 of sine of x to the 4th power dx. And hopefully you see where this is going. Now we can apply the same thing to integral from 0 to pi over 2 of sine of x to the 4th power dx, and we are going to get some constant times integral from 0 to pi over 2 of sine squared of x dx. And if we really want to, we can go one more time integrating sine squared of x dx to get some constant times integral from 0 to pi over 2 of sine of x to the 0th power dx. And of course, sine of x to the 0th power is just 1. And we may conjecture, because sine of x to the 8th power is 7/8 this thing, sine of x to the 6th power is going to be 5/6 this thing, and sine of x to the 4th power is going to be 3/4, and the sine of x squared is going to be 1/2 the integral. And of course, integral from 0 to pi over 2 of 1 dx is pi over 2. And from this pretty organized pattern that we are assuming, we can conjecture that the integral that we want to find evaluates to 7/8 times this integral, which is 5/6, times this integral, which is 3/4, times this integral, which is 1/2 times pi over 2, times 1/2 times pi over 2. So we are saying our integral is going to evaluate to this thing. And what do we get when we multiply this out? 3 and 6 cancel out, leaving 2 down below. And we are going to have 7 times 5, 35 pi over 16, 64, 128, 256. So it looks like our answer is 35 pi over 256. But before we are 100% sure of our answer, we have to prove our assumption. So to get our answer, we have conjectured from the evidence for sine of x to the 8th power that integral from 0 to pi over 2 of sine of x to some even power, 2n power, x dx is over 2n over the same exponent over 2n, and the top is going to be 1 less than that, times the integral from 0 to pi over 2 of sine of 2n minus 2, so the even number right below 2n, x dx. So we have assumed this, so this is what we want to show. And we can prove this exactly the same way as we simplified our original integral to sine of x to the 6th power. All we have to do is do integration by parts. So let's give ourselves a little bit more space to work with. So we are integrating sine of x to the 2n power from 0 to pi over 2, and using the same reasoning as sine of x to the 8th power, we are going to let our u be sine of x to the 2n minus 1 power, and dv be sine of x dx. Differentiating this, we get 2n minus 1 times sine of x to the 2n minus 2 times cosine of x dx, and the anti-differentiating sine of x gets us negative cosine of x. So we get that this thing is equal to uv, or sine of x to the 2n minus 1st power times cosine of x times negative 1 from 0 to pi over 2 minus integral of v du, minus minus is plus integral from 0 to pi over 2 of 2n minus 1 times sine of x to the 2n minus 2 power times cosine squared of x, and we are writing cosine squared of x as 1 minus sine squared of x. And of course, this entire thing is 0 because cosine of pi over 2 is 0 and the sine of 0 is 0. So that's going to go away. And this thing is going to be integral from 0 to pi over 2. 2n minus 1 comes out of sine of x to the 2n minus 2 power minus 2n minus 1 times integral from 0 to pi over 2 of sine of x to the 2n power dx. We are distributing this, splitting up the integral. So we are doing the same thing we did. And we know this entire thing is equal to the original integral, which I'm going to say is I sub n. So this entire thing is I sub n. So we get that our I sub n, let's finish it up, I sub n is equal to 2n minus 1 of I sub n minus 1, because we have the even number right below it. That's 2 times n minus 1 minus 2n minus 1 times I sub n. Moving this over to the left side, we get that I sub n times, that's 1 times I sub n, so 1 plus 2n minus 1 is going to be 2n is equal to 2n minus 1 times I sub n minus 1, which gets us that I sub n is 2n minus 1 over 2n times I sub n minus 1, and that's exactly what we wanted to prove, 2n minus 1 over 2n of integral of the even number right below it. So we have proven our assumption. So we have shown that our integral evaluates to 35 pi over 256. But before I finish up, I want to point one more thing out. Realize that using our recurrence relation, we got that integral from 0 to pi over 2 of sine of x to the 8th power dx is 7 times 5 times 3 times 1, which is 7 double factorial, over 8 times 6 times 4 times 2, which is 8 double factorial times pi over 2. And obviously you can generalize this to any even power. So we know integral from 0 to pi over 2 of sine of x to the 2n power dx is equal to 2n minus 1 double factorial over 2n double factorial times pi over 2. And it's interesting to point out that this formula also works for n equals to 0, because integral from 0 to pi over 2 of 1 dx, that's pi over 2, and negative 1 double factorial and 0 double factorial is defined to be 1. So we are going to get pi over 2 as we desire. So obviously we can now evaluate integral from 0 to pi over 2 of sine of x to the 20/18th power dx instantaneously. That's going to be 2017 double factorial over 2018 double factorial times pi over 2. Anyway, let's go back up and write our answer all the way back up. So we have shown that our integral is equal to 35 pi over 256, and we are done.